All right, as we talked before about the greatest common factor, we're going to have a new thing today is how to use the greatest common factor in solving problems by grouping. How can we do that? Let's take an example for that. If I say five x plus 15 yx plus 3y. Look at this example. Looks complicated. Can we make that in two products together? I think that it's, or two product of two polynomials. That looks difficult, but let's try that. Look at this. How about making them like this? 5x plus 15. This is the idea of grouping, is to put them in a group. I put the first two terms in a group. Plus, get the plus down. yx plus 3y. By the way, I would like to mention something. What if I put minus here? Be careful that you distribute the minus. So minus times plus equals minus. So it doesn't match that. So if there is minus here, you have to make this minus. So minus times minus equals plus. And we're going to see that later. So it's the same right now, so no change for this one. Okay, I put them in two different groups. Okay, the first step that we have learned before is to get the GFC. And I see here that this is 5 and this is 15, so my GFC would be what? Yes, it is 5. So 5x plus 3. Cool. Let's go to the other one. yx and 3y. Oh, it sounds like y. So y is the GFC here. So let me get y down. And this is yx, so that would be x plus 3y divided by y, so that would be 3. I want to make sure that this is right from that. Distribute. This is equal 5x plus 15 plus yx plus 3y. Don't scared. It's very easy. Just be brave. Okay. Look at this. This is a new thing. This is the same like this. Can I consider this a common factor? Greatest common factor? Oh, yes. Let me get that out. X plus 3. So what's left here? This is 5. And what's left here? Y. So that would be 5 plus y. And from that, I got a product of two polynomial here. Okay, I want to make sure that this is the right answer. Let's do distribution. X times 5 plus y plus 3 times 5 plus y. 5x plus xy plus, plus 15 plus 3y. Is it the same? 5x, xy, or yx, 15, and 3y. So my answer is correct. Okay, from this example, we have known how to use the grouping method to solve a polynomial like that. Let's take a more difficult one to be familiar with those kind of problems. So let's go through it. This is example number 2. 4yx plus 15 minus 12x minus 5y. I need to manipulate with this a little. I need to arrange it, because I can take this with that. But if I group those together, I don't have any common factor, any greatest common factor between them. But if I get this with the guy, 4 and 12, oh yeah, there is 3. And x, there is x as a common factor as well. So let's try that. 4yx minus 12x. And the other one, I will say minus 5y plus 15. Is that correct? No. Why? Do you remember what I told in the first example? Try to get this down. Negative times plus 15. What would we get? We give me negative 15. Is this negative 15? No. So how can I make this negative? How can I make this positive 15? I need to make this negative. So negative times the negative is what? Is positive. I know it's a little tricky, but this is the only way, is to make it a perfect way. Now, I have two groups, 4yx minus 12x, and another group, 5y minus 15, and there is minus in between. Okay? So, let's try to get the common factor of the first one. 4 and 12, the common factor is 3. Y, oh no, there is no y here. X, okay, there is x here. Excuse me, this is 4, I'm sorry. 4 is gone, and there is x, so that would be y, and 12 divided by 4 is 3, so, and x is gone already. Minus. What is the common factor here? It's 5. So 5y divided by 5 is y minus 15 divided by 5 is 3. Look at this. This is the same thing. So here I would say that y minus 3 times 4x minus 5. Again, I need to check that to make sure that my answer is correct. Especially, this is a tricky one. So y times 4x, excuse me, 4x minus 5, minus 3 times 4x minus 5. So y for xy minus 5y minus 12x plus 15. 4xy minus 5y minus 12x and 15. Correct. Cool. So now I could conclude that I have 4 steps to solve this kind of problems. Number 1, the first thing is to group the terms in 2 groups of 2 terms. So each group has a common factor. I grouped those in two groups. Each group has two terms here, and so that I can factor each group. Step 2, factor out the greatest common factor for each group. I got 4x here as greatest common factor for that group, and 5 as the greatest common factor for this one. And then, step 3, if there is now a binomial factor in the group, factor it out. You see the binomial here? Y minus 3, y minus 3. So I factored it out, y minus 3. And what's left? This is the step, excuse me. And then we get the left in another binomial, 4x minus 5. If not, if I cannot find that, try to rearrange it again so that you can find a way to factor it. Okay, so this is the 4 steps to solve the factoring by grouping. Let's get another example, so quick. Three xy minus 3ay minus 6ax plus 6a squared a squared. Okay, let's check that. First of all, I need to group two groups of two terms. So I'm going to take 3xy. I want another one so that I can get a greatest common factor with that one. I could get this one, because there is 3 as a common factor, and as well as y, right? So how about this? Minus, be careful again, it's minus 6ax. What should I put here? Plus or minus? Minus. Thank you. 6a squared. So 3y, this is my common, greatest common factor here. This is x minus a minus 6 and 6, get it out. What is common factor here? A and a squared. So I can get a, the smallest degree. So here going to be ax. Here's 6, and I take a. A squared is what? Is a times a, right? So I take a out, so still 1a inside. So it'd be like this. Step number 3 says that if there now a binomial factor, and the group factor it out, x minus a, and that would be 3y minus 6a. And that's it. And by this example, we are done with factor by grouping.